Hello, and welcome to a video on exam questions part 1, brought to you by the Answer series. In the next two videos, we're going to be looking at how everything comes together in exam questions. Example number 1, I want you to pause the video, I want you to try these, and then we'll do them together. The first example, they've given you brackets equal to 0. This question is only worth 2 marks. Do not multiply the brackets out, because if you multiply them, you're going to have to factorize them again. So they've given it to you in factorized form. 2 brackets multiply to give you 0. One of them must be 0. So either x is a third or x is minus 4. Number 1.2, they've told you to solve correct to 2 decimal places, which means you need to use the quadratic formula. A is 2, B is 9, C is minus 14. There's my quadratic formula. Substitute the values in, use your calculator, and you get your 2 answers. Number 1.3 is a surd equation. I've got the square root on its own on one side, so I can square both sides. Remember, when you get a square root squared, you're just left with what's underneath, and that becomes 9x squared. Set up a quadratic, factorize, and get your 2 answers. And then remember, if you have a surd equation, you have to check your answers back. So if x is 1 over 9, I substitute into the left-hand side, and I get an answer of 1/3. 3 times 1 over 9 on the right-hand side, I also get an answer of 1/3. Because the left and the right-hand sides are the same, it means that x is 1 over 9 is a solution. What about if x is minus 3? I substitute into the left-hand side, and I get 9. If x is minus 3, I substitute into the right-hand side, and I get minus 9. Because these are different, x cannot equal minus 3. Number 1.4 is a quadratic inequality. The first thing I do is multiply the brackets. I then set up my quadratic, which I factorize. I have a positive x squared, so my graph looks like this, with zeros of minus 1 and 7. I want where this is greater than 0, in other words, that part and that part. So it's when x is less than minus 1, or when x is greater than 7. Example number 2. I want you to pause the video, I want you to try this one, and then we'll look at it together. I can take the square root of 16, but I can't get the square root of x to the 7 unless I go into fractions, which I don't want to do. So what I do with the x to the 7 is I break it up into x to the 6 times x. Now x to the 6 I can take the square root of. I do the same with this x to the 7 as well. The square root of 16 is 4. The square root of x to the 6 is x cubed, and I'm left with root x. Square root of 25 is 5. Square root of x to the 6 is x cubed, and again I'm left with root x. Now, these terms on the top are like terms. I've got 4 of these x cubed root x minus 5 of the same x cubed root x. 4 minus 5 is minus 1 of those x cubed root x terms. The root x's cancel, and I'm left just with minus x cubed. Example number 3 is a simultaneous equation. I want you to pause the video. I want you to try this, and then we'll look at it together. I take the linear equation. I always want to avoid fractions if I can, so I make x the subject of the formula, and x is equal to 2y plus 3. Now, that x is the same as this x, so in place of x, I'm going to put 2y plus 3. Multiply the brackets, set up the quadratic. Remember, the quadratic is in y, so when I factorize, make sure those are y's, and you solve for y. Substitute back into this equation here, and you get your corresponding values of x. So x is 6, y is 3 over 2, or x is minus 3, and y is minus 3. Example number 4 is a problem-solving question. It says to you, prove that x squared plus 2xy plus 2y squared cannot be negative for x and y real numbers. Pause the video, try this, and then we'll look at it together. What I need to do is I need to take this and I need to break it up somehow. And this is why it's a problem-solving question, because there's been no hint given to you whatsoever. What I do is I take the 2y squared and I break it up into y squared plus y squared. Why have I done that? Well, x squared plus 2xy plus y squared, I can factorize into x plus y all squared. And then I've just got the plus y squared on the end. Now, what do you know about a bracket squared? You know that it's greater than or equal to 0. What do you know about y squared? You know that it also is greater than or equal to 0. And remember, they told you that x and y are real numbers. So I don't need to worry about what happens if x and y are square roots of negatives and things like that. Because we're dealing with real numbers, x plus y all squared is always greater than or equal to 0. Y squared is always greater than or equal to 0. And if I add two things that are greater than or equal to 0, my answer has to be greater than or equal to 0, which means that x squared plus 2xy plus 2y squared cannot be negative. And that was what I was asked to prove.
Check out the video description below for practice questions from our study guides. If you found this video useful, give it a like and subscribe to our channel so you don't miss any new episodes. Follow us on Instagram or Facebook to stay on top of the latest TAS news and launches. So that's it for now from the Answer Series, your key to exam success.